Problem 3.29 is a relative motion problem. In this problem, you wish to row across a river 63 meters wide, and you can row at a steady rate of 1.3 meters per second. Now that's relative to the water, okay? And the river flows at 0.57 meters per second. What direction should you head? That means what direction should you row, and how long will it take you to cross the river? Okay, so we've got a river. There's its banks, and it's got a certain width, okay, which is given to you. Now the problem is you have to point whatever it is you're in, okay, it says row, so I assume that's a rowboat, upstream so that when the water pushes you downstream, you have just the right angle so that you go across. So this is the velocity that the engine, which is u, gives the boat. This is the velocity that the water has going downstream, and then this is the velocity relative to the ground, and that's the direction that you want to go across the stream. Okay. What you're going to look for is this angle right here, theta. You got to know what direction you're going to point that. And then you want to know the time that it takes to cross the stream, okay? So what's given is the velocity that you can row. I call it the velocity of the engine. You're the engine, okay? That's 1.3 meters per second. The width of the river is 63 meters. And the velocity of the current, I call that the velocity of the water, is 0.57 meters per second. Okay. Well, I've set the problem. This is the solution to the problem right here. Okay. By the way, the unknown is theta and the time it takes to cross the river. Okay. But basically, your theory, the basic theory, is that the velocity with respect to the ground, that is what we're going to see the boat do as an observer on the ground, is going to equal to the velocity that you give the boat plus the velocity that the river gives to the boat. Okay, so there's the theory right there. And this triangle right here shows the addition of those vectors. This vector is the sum of that vector plus that vector. And you've got some geometry here because you know the basically the side of the two, the hypotenuse in one side of the right triangle, okay? We'll also need to find the time, and the theory of that would be, of course, be equal to the time would be equal to the width of the river times the velocity across the river, okay? So we can do those two calculations. Now, the solution's pretty simple if you look at it. Since that's a right triangle, okay, the angle theta, which we're looking for, would be equal to the inverse sine of v of the water over velocity of the engine, which is given. Okay, so that's pretty easy to do. That's the angle that you got to point upstream. Okay, this is for the A part, and you can work out the details on that. And then on the B part, that's just a simple plug-in. Okay, actually there it is right there. So just simply take that width, which is 63 meters, and divide it by the result. Well, you're going to have to find V sub g, I suppose, also. So V sub g, and then V sub g is going to be equal to a VE times the cosine of theta. Whoops, cosine of theta. So if you'll find that and plug it in there, then you'll get the time.